All right, Morgan, we hope you're feeling better. I hope those tonsils are doing good. So have a popsicle. Whoops, need a red one, I guess. Okay, so our goal today, one of our goals is to talk about functions and what is a function, what's not. So we're looking at the vertical line test. Vertical line test says that if the vertical line crosses the graph in more than one spot, then it's not a function. So if you draw these four shapes down, we'll drag the vertical line across and decide whether it's a function or not. So how about the first one? For two answers, yes and no. Yes, it is a function. How about the second one? No, you can see our definition is for every input, there's exactly one output. Well, if you have an input of 1, you have two outputs. If you have an input of -4, you have two outputs. So this is not a function. How about this one? There's no domain values here. So the idea here is that if it's drawn like this, it's headed up towards the y-axis. It gets infinitely close but never touches the y. The way I drew it, maybe I did draw it completely vertical. Actually, maybe I actually arched over to the other side. I apologize, but that's what's intended to kind of look there. I'll be very clear if I ask these questions on the test. And then this last one here, as you look, how about this one? Yeah, it definitely falls apart right there. That's definitely a vertical line, right? Okay, so we have no, I'm sorry, yes, no, yes, and no. So now instead of looking at the graph, because that's easy, right? Instead of looking at the graph, let's look at the actual equation. Maybe we can look at an equation and identify whether or not it's a function. What do you think? First one? Nah. You don't? Okay. You think yes? How could I be convinced? Oh, wow. How do you know that? It's a circle. Circle centered at 0, 0 with a radius of 3. Exactly. But if we don't know about the graph, how can we show it algebraically? And the nice thing here is if you solve for y, then we can tell a lot. So if I subtract the 2x squared, I get a -4y is equal to -2x squared plus 8. So y is equal to 1/2 x squared minus 2. So the idea is now that I've solved for sides, if we take the square root, how many solutions do we come up with? Voodoo math. But come up with plus or minus the square root of 9 minus x squared. So what that means is if we input 0, 9 minus 0 squared is 9. Square root of 9, it tells us is a positive and a -3. This one is because, as we've solved for y, if you plug something in, you just get out one output. If it said plus and minus, then you would have two outputs, and we would be more concerned. So in this situation, we could write it y and just an x over here, so we're confident that it will work. The last one, if we add the y to the third over, I'm going to cube root both sides. And I get the cubed root of x plus 3 is equal to y. Namely, if you plug in something for x, you're just going to get one output. So you can see if there is an even root, like a square root, you're in trouble. If it's an odd root, okay, you're going to be okay. All right? Don't worry too much about that. Just want you to see that this was definitely not a function due to the x squared and the y squared. That's kind of the tipping point. The last one is yes. And we will build on that. You'll start to understand why those are functions even more as we move along. Okay, so now we get to the last piece. This is the last piece of notes we need to do. We need to talk about piecewise functions. Now, just to refresh your memory, I told you how to evaluate f of 0 earlier, right? What is f of 0? Do I plug 0 into the top one or the bottom one? Top one, why? Because 0 is less than 2, and you get 3. So f of 0 is 3, okay? So this function is kind of unique. And don't draw what I'm going to draw right now, but in order to get an idea of what this looks like, I have to look at this graph, which is y equals 3, and I have to look at this graph, which is y equals x minus 4. What does the graph of y equals 3 look like? Horizontal line through 3. What does the graph of y equals x minus 4 look like? It goes through -4 and has a slope of 1. Now, if we put the two together, that's what we get. But is that a function? No, it's not. Why? Yeah, it doesn't pass the vertical line test, does it? So we have a problem. And the problem lies in the domain restriction. The domain says that x should be less than 2 for this one. So that means I want this graph, but only when x is less than 2. In other words, I want to get rid of that part of the graph. And then I want y is x minus 4, or this slanted line, when x is greater than 2. So I want to get rid of that part of the graph. Would it be a function now? Yeah, so let me show you the best way to graph these. And this is it's a new learning for you. It's very important for calculus. You're going to want to focus on how we graph these. You're going to have this to have success moving forward. I like to come up with the endpoints first. And I know that something special happens at 2. So when I plug in 2, what is the output? The output is always 3, right? I'm going to plug in 2 for the top and the bottom, okay? Now, I get the point 2, 3. Are you going to have an open or closed circle at 2, 3? Open circle at 2, 3. And then it's going to head off in that direction because you want to draw the graph of 3 for x values less than 2. So if anybody has one of those non-listening moments where you're like, oh, I wonder what I'm going to have for supper tonight, or something like that, you should raise your hand and let us know, so then we kind of join in the fun. You know what I mean? Every once in a while, I actually have one I'm teaching if I get bored with it. Hasn't happened for a little while, but did happen early on. Yes. Where'd I get the what? I got the 2 because that's where something interesting happens. That's where my break happens. Okay, let's plug in the 2 for the bottom. If I plug 2 into the bottom one, what do you get? Excellent try. Try again. -2. All right. So we got 2, -2. When I plug, because 2 minus 4 is -2. Right? Awesome. Work through confusion. Open or closed circle? Closed. Now, you tell me, should I draw this line down through -4, or should I draw it up to the right? Why? Because I want to draw it for values that are greater than 2, so over in this direction. And that's what you get, and that's my piecewise function. So we've kind of opened up your brain to a new piece of thinking. Let's try to connect some dots in this middle one and then secure it with the last one. So let's first get an idea of what the heck this looks like. What does x plus 3 look like? Okay, it's a line that starts at 3, or actually goes through 3. It doesn't really, it starts way back at -infinity. And then what does the next graph look like? X squared. Parabola centered at 0, 0. So those are my 2 shapes, but that's not a function right now, is it? So we just need certain parts of it. So let's do the first one. What do I plug in for the x value? When you plug in -1 to the top one, what do you get? Dose. -1, 2, open or closed circle. Very good. Now, where do I go from there? Should I go up through the 3, or should I go down to the left? Down to the left. Why? Because I'm going to carry the values that are less than or equal to 1. Stop laughing, Terry. Exactly, and that's the confusing thing that people deal with. And so when I draw it like this, people are like, but you just drew a negative slope. I didn't because we measure slope going from left to right. So left to right, we're going up. Okay? So that's the part that people get confused with. Okay, I plug in -1 to the bottom one. What do you get? 1. Okay, open or close circle. Open. Now, where should I go from there? To the left or right? To the right. And what point should I go through? Who said 0, 0? Way to go, Terry. Yeah, you know that this thing is centered at 0, 0. So it looks like that. 2, 4 would be another point on there. 1, 1 would be a point on there. Okay? What's different about this last one? There's 3 graphs. Let's talk about the shape. 4 minus x squared. What does it look like? Parabola, upside down or right side up? Shifted. Blah. Up 4. Okay, great. Got that. How about -2? It's just a line that goes through -2. Awesome. How about x minus 5? Something like that, right? So I got 3 pieces. Obviously, that can't be our function. We've got to cut it up into certain sections. So, but at least we know what we're kind of looking at for shapes. So let's do the first one. What's the first number we plug in? 1. And you get 3. Open or close circle? Open. Where do I go from there? To the left or the right? I go to the left. And where does it go? What's a point it goes through? It's going to go up to 4 and then down through -2. How do I know it went through 4 and -2? Yeah, those are the x and y intercepts. Remember how we covered x and y intercepts? Yeah, this factors to 2 plus x and 2 minus x. Also, if you plug in 0 for x, you get 4 for y. Okay, let's do the middle one now. We got to plug in 1. If you plug in 1, you get -2. Open or close circle. Okay, I should plug in another one. I'll plug in 3, and you get -2. Open or close circle. So it's just that short little segment. You told me it was a horizontal line, but that's all we want for the horizontal line. So you can see that for this middle one, I had to plug in 2 points because it's got 2 endpoints. Then for the very last one, I plug in 3. And what do you get? -2. Open or close circle? Open. So should I head off through -5 or should I go off to the right? To the right with a slope of 1. And that's my graph. So right now, what's great is that your learning is very fresh. If you want to solidify it, you have to practice it and then sleep. Then it converts to long-term memory. You might have to skip morning swim practice. Joe's laughing. Okay, all right. You swimmers, you guys put in a lot of hours. You're tired. Let's do an assignment so we can solidify your learning. There you go. Yeah.